ABCD is a quadrilateral with vertices A, B, C, and D. Determine the coordinates of M, the midpoint of A and C. Right? 1.1. 1.1. Determine the midpoint M of A and C, which is going to be x of A plus x of C divided by 2, y of A plus y of C divided by 2 are the coordinates of the midpoint AC. Midpoint AC is equals to this. Alright. We go back, we say, what are the coordinates of A? Is 3 and 0. The coordinates of, so it's -3 and 2. Right. For A is -3 plus 2 divided by 2. For Y is going to be 0 and -1. 0 plus -1, all divided by 2. So A, the midpoint of AC, is going to be equals to this, and that is going to be -1, all divided by 2. This and that is going to be -1, all divided by 2. So the midpoint of AC is going to be 1 over 2, -1 over 2, and -1 over 2. If we come back here, the midpoint of AC, which is this line here, is going to be somewhere along here, which is negative and is negative, 100%. Show that AC and BD, which is this line here, bisect each other. The most important part is this part here, bisect each other. Right? Bisect each other means they cut each other at a certain point that makes this part equals to this part and this part equals to this part. So simply put, if in this case this is D, this is B, this is A, and this is C, the way to prove that AC and BD bisect each other, it is by proving that midpoint of AC is equals to midpoint of BD. Right? So we go 1.2. We say what is the midpoint of BD? Is going to be equal, like before, x of B plus x of D divided by 2, y of B plus y of D divided by 2. Right? And then we proceed. Oh, the page is finished. Alright. How do we add a page here? New page. Right. We add a page. Alright, we say MBD, which is the midpoint of BD, is going to be, what is the x of B? The x of B is -1. What is the x of D? The x of D is 0, all divided by 2. What is the y of B? The y of B is -3, plus what is the y of D? The y of D is +2, all divided by 2. So MBD is equals to -1 plus 0 is -1 divided by 2, plus -3 plus 2 is no, it's not a plus, it's coordinates. It's coordinates. -3 plus 2 is -1, all divided by 2. So therefore, the midpoint of MD is equals to the midpoint, or is the same as the midpoint of AC. Therefore, BD and AC bisect each other. That is the proof right there. Okay, next. Prove. Let's remove all of this before we proceed. Right? 1.3. Prove that ADC is equals to 90 degrees. Alright. How do we prove that ADC is equals to 90 degrees? It is by proving that the gradient, right? The gradient of AC, which is also, not to confuse you, gonna be represented, which is also going to be represented as M. We are supposed to find the gradient of AD and the gradient of DC. The product of these two should be -1, which is the gradient of AD multiplied by the gradient of DC should be equals to -1. It means they are perpendicular to each other, right? This by no means is the same as the midpoint. These are not the midpoints, but for some weird reason they used M for both sides. So these are not the midpoints. So let's proceed. We say we're looking for the gradient of AD and the gradient of DC. We say 1.3, which is gradient of AD is going to be y of d minus y of A, or divided by x of d minus x of A, is equals to y of d is 2, y of A is 0, divided by x of d is 0, and x of A is -3. 0 minus -3. Hold on, let's not make a mistake. X of d is 0. No rush. Minus x of A is -3. It's going to be 2, all divided by 3. And then we then say, let's add a page, new page. And then we then say, let's also find the gradient of DC, which is gradient of DC, is going to be equals to y of C minus y of D, all divided by x of C minus, minus x of D. This is equals to y of C is -1, minus y of D is 2, all divided x of C, in this case x of C is 2, x of C is 2 minus y of x of D is 0. X of D is 0. This is equals to -1 minus 2, all divided by 2 minus 0 is 2. All of this is gradient of DC, this is gradient of DC, this is gradient of DC. Minus 1 is minus 3 divided by 2. Therefore, we say MDC multiply by MAD is equals to, remember, MAD is this, MDC is this. MDC is minus 3, all divided by 2, minus MAD. Wait. MAD. What is it? It's AD. It's AD. It's AD. This one is D. Apologies. This one is D. This one is D. Right? And then MAD is 2 over 3. These two is going to make negative 1. Therefore, MDC, the gradient of DC, multiplied by the gradient of AD is equals to negative 1, which means that DC is perpendicular to AD. Perpendicular means they meet at 90 degrees. That is what perpendicular means. They meet at 90 degrees. When you go back here, you say, this simply means if this was to be continued and this was to be continued, this would be 90, this would be 90, that would be 90, and that would be 90. And it proves our point that ADC, which is this, is 90 degrees. It proves our point. Okay, cool. Let's move on to the next one. The next one is going to be show that ABCD is a square. How you can show that ABCD is a square? It is by showing, since already this is proven to be 90 degrees, it's going to be 6 marks. You can prove that this is equals to this, is equals to this, is equals to this, and maybe that this and this, and that this is also 90 degrees. So let's get to work. We have prove, okay, 1.4. 1.4. Prove or show that ABCD is a square. How you prove that? It is by proving that AD is equals to DC is equals to CD, no, is equals to CB is equals to AB. To make this easy, let's write all these coordinates first here so that we can continue without having to go back and forth. Okay, cool. The coordinates of A is minus 3 and 0. Minus 3 and 0. The coordinate of D is 0 and 2. Is 0 and 2. The coordinate of C is 2 and minus 1. The coordinate of B is minus 1 and minus 3. Minus 1 and minus 3. Let's just verify that minus 1 and minus 3. So if we proceed to prove that all of these are equal, we then go, okay, AD is equals to square root. I'm going to start with, okay, A minus 3, D minus 0 squared, plus bracket, right, 0 minus 2 squared. AD is equals to 3 squared, 9, 4 is 13, square root of 13. Let's go with DC. We go DC again, just like here, right? DC D0 minus C minus 2 squared plus bracket D is 2 minus C minus 1 squared. Okay, square root, boom. This 4, this plus 2 plus 1 squared. 4 plus 9 square root is equals to square root of 13. Alright, let's do CB. CB is equals to square root C 2 B minus 1 squared plus C minus 1 minus B minus 3 squared. Add a page. Add a page. Is equals to square root. This and this is 3 squared plus this and this and that and that and that is going to be 4. Now it's going to be minus 4 squared. It's going to be plus, right? This and that. Whoa, am I making a mistake here? It's 3 CB. Okay, I made a mistake somewhere. Let's remove all of this. Let's try it again. Right. Let me just verify if CB is the side of this triangle, of this square. CB. Okay. CB is what? CB. B is minus 3 minus 3. Minus 1 minus 3. C is 2 minus 1. Okay, cool. All is well. Right? Bracket. All is well. Bracket. X of C is 2 minus X of B is minus 1. All squared. Plus Y of C is minus 1 minus Y of B is minus 3 all squared. Hold on, something is not adding up here. It's 3. Oh yes, everything is adding up. I made a mistake. Right, perfect. 2 plus 1 squared plus minus 1 plus 3 squared. Square root of 3 squared plus this and this 2 squared is equals to square root 9 plus 4 is equals to square root of 13. What is the last one? AB. AB is going to be equals to square root X of A minus 3. X of B minus 1 plus Y of A 0. Y of B minus 3. Square root. Right, boom. And then you say minus 3 plus 1 is minus 2 squared plus 0 plus is plus 3 squared. 4 plus 9 square root of 13. Therefore, A is equals to CB. AB is equals to CB is equals to DC is equals to AD. Right? And then I must prove that the opposite angles. I don't know if this is a complete proof, but I know for a fact if you can prove now that this is also 90 degrees, you have proven it. Because if all sides are equal and the sides that are equal are opposite to, and the angles that are opposite to each other are equals to 90 degrees, if all sides are equal, right? And the sine and the angles that are opposite to each other are equal to 90 degrees, it is a square. Because it does not make it automatically to be a square if all sides are equal. Because all sides can be equal, but it's just something like that. But this one is another angle, and this is another angle, and this is another angle. It only becomes a square if also the opposite angles are equal to 90 degrees each. Because if these two are